7.1 was all about this new idea on a sampling distribution. So remember we said that no longer does a dot mean one item. A dot now represents the summary statistics of more than one item. So maybe it's the mean or the median or the interquartile range, or like with the German tank problem, we saw lots of different ways to analyze this summary statistics there. So remember, a dot no longer means one thing. So this is going to be a continuation of that. We're actually going to be talking about what happens when we combine our dots, meaning proportions. Okay, so the example that we're going to be looking at in the practice activity is flipping a coin and recording the proportion of heads. So if I were to just take a coin and flip it and then just go heads, tails, heads, tails, heads, tails, the data is just not that exciting and it could be all over the place. So what we're going to do instead is we're going to say out of 30 flips, what's the percentage that you get heads? So you can look and see what those percentages are, or proportions. So basically, we're still working with those sampling distributions. Remember from before, sampling distribution means a dot does not mean a dot. A dot means, in this case, it's a proportion of a sample. So you have a sample, you figure out a proportion that represents that sample, and then you plot that proportion. So the mean is actually really, really simple. Your mean of your sampling distribution is that proportion. So for instance, if you go back to the heads and tails things that I just gave you, the proportion of getting a heads would be 0.5 because that is what the proportion is. So the proportion of the sampling distribution is equal to the population proportion, which is P. So in this case, it'd be 0.5. Now, how do you find the standard deviation? Standard deviation is the square root of P times 1 minus P all over N. And for those of you that are in AP, you'll notice the little box over here to the side says that the formulas are given to you on the AP reference paper. So you should probably pause the video at this point and see if you can locate where those formulas are. I believe they are on the bottom left-hand corner of your first page. Okay, so in order to use the standard deviation, you do need to check that the 10% condition is satisfied. Remember this from, I think it was 2 videos ago. We talked about the 10% condition. I don't write it like this. I write it as 10 times your sample has to be less than or equal to your population. This is something you should always check when it comes to standard deviation because it's the independence piece. You need to establish that the independence exists before you can use the standard deviation. Now, the other piece that's also very cool about this is the bigger your sample size, you can usually establish that your sampling distribution will become more normal. And I think I said this in one of the other videos. As soon as something becomes more normal, we can do more with it. We can calculate more probabilities, which is very, very useful. So your large counts condition is n times p has to be greater than or equal to 10, and n times 1 minus p also has to be greater than or equal to 10. So I'm going to take you through one example, and that's it. This video is very straight to the point. We've got our sampling distribution of our sampling proportion. We've figured out our mean is our proportion. There's the formula for standard deviation as long as your 10% condition or your condition for independence is satisfied, and then check to be normal. If all those things are right, then you can calculate probabilities. So here's the example. A superintendent of a large, keyword here is large, school district wants to know what proportion of middle school students in her district are planning to attend a 4-year college or university. Suppose that 80%, so right there is your P. So P is equal to 0.8. That's going to be very useful. Of all middle school students in her district are planning on attending a 4-year college or university. What is the probability that in a simple random sample of size 125, so I'm going to say n is equal to 125 because n always represents your sample size, that will give a result within 7 percentage points of the true value. So I want to be 7 percentage points of this 80. So I want to know what my probability is of being between 0.73 or 73%, which is less than or equal to P, which is less than or equal to 0.87 or 87%. So that's my final step, is that I'm going to be finding that probability. Now, in order to do this, I want to be able to use a normal probability distribution. So we know that we want to use normal CDF, and we need our lower, which actually I could just fill in because I already know what that is. My lower is going to be the 0.73. My upper will be 0.87, and then it asks for the mean and the standard deviation. So I need to know what the mean and the standard deviation are. So we're going to come over here, and if you remember from the previous slide, I said the mean of your sample proportion is equal to P, which in our case is equal to 0.8. So that means my mean is 0.8. I also need my standard deviation. So the standard deviation of the sample proportion is equal to the square root of P times 1 minus P all over N, which is equal to the square root of 0.8 times 0.2. And again, I got that just from 1 minus 0.8. And then that's over 125. And then you would type that in the calculator very carefully, and you would get 0.036. So that would be comma 0.036 right there. Now, a couple things to check. We do need to check that 10% condition in order to be able to use this right here. So 10% says 10 times your sample size, 125, is equal to 1,250, which has to be less than or equal to N. N is your population. So N is all middle school students at the large district. And I hope that you would know that if it's a large district, then they're going to have more than 1,250 students. So I just checked my 10% condition. Again, in order to check 10% condition, you do 10 times your sample size, and that has to be less than your population. So we're going to assume that there are more than 1,250 middle school students at that large middle school. Okay, so there probably are or is. So therefore, we can assume that my standard deviation is 0.036. Now, I did also make the assumption that I could use this normal condition right here without checking, and I should check that. So normal, we're going to use our large counts. So that is n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. So let's check this one first. There's 125 students times 0.8. 125 times 0.8 is equal to 100. And then 125 times 0.2, because that's the opposite, the 1 minus p, that would be equal to 25. So both of those numbers, 100 and 25, are greater than or equal to 10. So therefore, I can assume normality. Now, I'm sorry, this is a mess. I should have probably wrote this a little bit more linear, but there you go. So I'm going to summarize in just a moment. Make sure that you label these. This is my min. This is my max. This is my mean. This is my standard deviation. And then I would plug it all into the calculator. Again, if you need a refresher, it's under second. Distributions are vars, and there's that normal CDF. You type in everything that's right there, and you're going to get that the probability is 0.9482. So you have about a 95% chance that between 73% and 87% will be the true proportion of students that, middle school students that go to a 4-year school. Okay, so a couple things to note here. What I did first was I wrote down the givens. So my givens were that P and that N. And then I wrote down what I was looking for. So that's my probability over there. Then I found my mean and my standard deviation. In order to use standard deviation, I had to check that 10% condition. In order to use normal, I had to check that large counts condition, which is all right there. And then I plugged it in the calculator and got my answer, and then answered it as in 0.9482 would be the probability. So a couple of things to note. As your n increases, your distribution becomes more normal, so it gets rid of the outliers. I'm hoping in class to be able to do a simulation so that you can see this. It's so cool if I can get it to work. There's your mean and your standard deviation formula. And again, this is the formula for proportions. The next video will be on what to do for means.